Okay, I hope that you can hear me. Thank you for giving me the opportunity to be here with you this afternoon and present FOSSbot. FOSSbot is our project that we're working with my student and the Greek free open source software community for the last 3 years. It's something that evolved from previous works that we have done with my student, especially my PhD candidate, Christos Chronis. And its main purpose is to become an open source hardware and software robot that can be used for educational purposes. As you can see from these small pictures from different sides of the robot, it is fully printable except of the wheels. It has a variety of sensors and motors. It has 2 motors and odometers and accelerometers and gyroscopes in order to monitor the movement of the robot. It has some additional sensors, list of sensors for collecting data from the environment, but also for using them in order to set up different training educational activities. It has a speaker, it is rechargeable. And in addition, it has this Lego-like base on top, where you can plug different other components, and it also has a marker hole on the top left, and it has a pulling component behind so that you can grab different weights to the robot. And also it has some infrared line sensor. The idea is that we use a robot built on top of a Raspberry Pi Zero board with a set that is not predefined but can be expanded, a set of sensors that can be used for different activities. The setup that we have proposed so far has a cost of 90 to 120 euros, depending on the sensors and the running cost of Raspberry. It's fully customizable. You can remove sensors, you can put your own sensors if you want. It is easily repairable compared to commercial kits because you can repair only the sensor that is not working and so on. And of course, it is 3D printable. This is the QR code of the project on GitHub. There you can find a lot of different, let's say, hardware blueprints. You can also find code of different projects that I will talk to you in the next of my presentation concerning FOSSbot. So this is some pictures from the labs where some of my students are working on assembling the robot. Earlier in an earlier presentation, there was a discussion about the duration that takes to assemble a device, a 3D printed device. In our case, initially it took us 4 hours to assemble its FOSSbot and do all these cable works and tests in order to have it fully operable. This is how FOSSbot works. You can see in this video, it has various sensors to do this follow the line experiment, for example. It also has some distance sensors in front that look like its eyes. So when you put an obstacle in front, it will stop. When you remove the obstacle, it will continue. And this is a project that started from our students, especially under the lead of Christos Chronis, but it continues to evolve and acquire more students and also more different variations that I will show you next. And we're trying to promote this open project to schools around Greece and also to the academic community. From the very first moments, we realized that in order to acquire a wider audience, it was important to offer solutions to people that are not very good on open hardware, on printing, on assembling, on electronics. So we accompanied the hardware solution with a simulated FOSSbot so that there is no need for anyone to print or assemble. It was able it was possible to download the simulation platform, and every script that was running in the simulation was fully compatible with the real robot, and it was easily transferable to the real robot. And these are some maps, let's say some environments where we set up different activities, like the snakes and ladders activity on the left, or like the activity with the corridor there, and so on. So we had different setups, floor setups and obstacle setups that can learn students to that can help students to learn how to program FOSSbot. And for example, this is a follow the line, the result of a follow the line code written in FOSSbot within the simulation environment. But of course, it is important to explain how the robot can be programmed in order to allow different levels, let's say, of proficiency of students, with proficiency in programming. We try to create 3 different levels, let's say, of programming using the same stack. So on top of the hardware, we have a library, a software library written in Python, which is the FOSSbot library, and on top of this library, we develop different programming environments. First of all, we have this kindergarten mode, as we call it, where the small, let's say the younger students are able to drag and drop small tiles that move the robot front or turn the robot left and right, and that's it. So they have limited, let's say, opportunities in order to do some moving the robot around experiments. And this is the kindergarten mode, as you can see. So these are the options on the top left that the students have. They can move it back and forth or turn left or right, and they can solve activities like the one on the top left, on the bottom left, where they have to collect, let's say, to move the robot to the different tiles following the order of the numbers. So it's for preschool or first degrees of school activity. Then we use the same environment. Actually, this environment is based on the idea of Scratch or Blockly. Blockly is the environment that Google promotes for this purpose. So these are the tiles in Blockly. So we have developed all these routines behind each tile in order to be compatible with FOSSbot. And now you can use these tiles, this different set of tiles to program in Blockly and create your program. So for example, the obstacle avoidance, a dummy obstacle or naive obstacle avoidance algorithm says that you can move forward and then you can turn right when you detect an obstacle, and then start moving forward again, and then you can move right when you find another obstacle, and so on. So it's a script that you can run and write and run within the simulator, and then you can do the same thing in the real world by porting the code to the FOSSbot, to the real FOSSbot. This is the line following example once again. So this is the programming environment that can be used for primary school students or high school students that are learning how to program. And finally, we used Monaco, which is another software that allows to program everything in Python. So it allows better control of the library of FOSSbot and all the sensors and so on. So we developed a third different interface for programming. When we finished with all this, we started thinking of ways to allow more students, especially higher education students, computer science students, to start working with FOSSbot. We think that since FOSSbot is a robot and the library, it's a robot control library, and we have the simulation environment and the real robot, it would be more appealing for our students that do machine learning or AI and test different algorithms to test their algorithms on the simulated robot first, and then probably on the real FOSSbot, having something practical to work with. So here you can see a video from a thesis of one of our students that tried to implement a reinforcement learning algorithm to guide the robot to the target. The target is on the top of the screen and moves from one experiment to the other, and the robot starts from the bottom of the screen in random positions, and it tries to go to the target by avoiding the obstacles using only 3 sensors, the sensor pointing to the front and 2 sensors pointing to the side. So this is something in the simulated environment, but of course can be ported using Monaco to the real robot. So what we achieved so far, and this is also grace to the very big help of the Greek Free Open Source Software Society, which supported the development of FOSSbot through Google Summer of Code also events, and also by funding parts of the development through donation. We have now we have more than 5 contributors, but 5 contributors have participated in Google Summer of Code in the past few years to develop parts of the FOSSbot, either in the hardware part or in the software part. We printed 100 robots, and we assembled them, and we gave it to schools around Greece. And we have also used the simulated environment to train 1,000 or around 1,000 educators on the programming environment of FOSSbot. We're trying to participate in different conferences and events like this one, and we try to expand the community, both in Greece but also internationally. And also we try to put our ideas in practice and try to include FOSSbot in university curriculums through different projects as let's say a test solution in the beginning, but gradually to import them more permanently. We have already several students that are doing their master thesis, their degree thesis using FOSSbot, and we already have some scientific publications. And this is an Erasmus project that we ran this period through different universities around Europe, and a university from France, this Uni La Salle. And what we're trying to do there is try to bring educators from around Europe to use FOSSbot in their classrooms and give us feedback on what to have to improve. Concerning the design, concerning the simulation, concerning the hardware, and so on. I will show you later on some results that we had through this project, through steps. These are some good news that arrived to us without having, let's say, them prepared. So this is an example of a school in Greece that started using the open source, the open design of FOSSbot to create their own activities. So this is a variation of FOSSbot that has been created by high school students in Greece. They try to do a robot, a fire extinguishing robot for a robotic competition. So they use FOSSbot as their base example, and they program it using our stack. And this is another version of FOSSbot that we recently are working with. It's for another project that has to do with bigger robots that work in industrial environments, in a factory setup, for example. These robots are very, let's say, strict on what we can run on them, what operating system they have, what opportunities they have for sensors and everything. So we try to modify FOSSbot and use it as, let's say, an assistant for bigger robots to move around the factory environment. For the moment, what we have done, we have changed the design in order to allow it to take on top a LiDAR and collect information from different obstacles that may exist on a factory setup, and then transmit this information back to the bigger robots in order to help them navigate more efficiently. As you can see here, this is an example, once again, in a simulation, because we're still waiting for the LiDAR to put everything into practice. But this is FOSSbot, the modified FOSSbot that moves around the corridors of our university building and tries to construct the map of the building using the feedback, the input from the LiDAR. We also modified the operating system. We removed the core library of FOSSbot. We extended it by also adding the ROS2 operating system that can help us collect some specific types of input and solve some tasks easier. And this is how, if you wait a few seconds, you'll see the FOSSbot moving around and start constructing the map with all the information that it collects using ROS. So it's something that, at least in the simulated environment, was done in a few days. So now we are ready to port it to the real environment. So what's next is not actually next, because we have already done these things. This is the new version of FOSSbot. As I told you before, in the STEPS project, in the Erasmus project, we are trying to improve things. So one of the things was to improve the printing time from a bit less than 2 days to 20 hours, and also to improve the assembly time. So the next version of FOSSbot is smaller, it's more compact, and also some things concerning the assembly time are easier now. We have some modifications. We have done some modification, and this is the new version. The physical robot, the first images were simulated, and this is the physical robot printed and assembled. And the assembly time now is less than 40 minutes. So this is the design. Okay, the video is quite fast here. Everything is easily detached, and we plan to use, we have used in some cases magnets in order to easily remove the top, and we plan to update it a bit more and use it in several detachable parts. And this is the new PCB that we have designed in order to reduce the number of cables and the complexity that we had with the different cables. So this also helps in limiting a lot the time needed for the assembly. We are trying to update also the instructions to print, to assemble, to operate, to install the software, and so on. The software is installed in FOSSbot, actually. When you turn on the FOSSbot, it acts as an access point, and then you can connect to FOSSbot through your laptop, and you have all this environment that I showed you before. So it's, let's say, self-sustainable. You don't have to connect it by cable. You can use Wi-Fi to access it and have everything on FOSSbot. And this is the last thing that we did in order to help students and people interested to use FOSSbot that do not want even to install the simulated environment. They don't want to do anything. So we created a web-based simulation. We launched it in this platform, FOSSbot.gr. You can also use, you can log in there and use FOSSbot and try to program it without having access to the physical robot. And these are the different programming environments that we ported, the Monaco and the Blockly environment that now are inside the browser, and the simulator, the Godot simulator that we used on the browser. And finally, we added an interactive mode using the video camera, where instead of having tiles for smaller kids, for kindergarten students, we used this video camera input, and we have the different positions, right, left, top, and bottom, to move the robot back and forth, and to turn it to the left and to the right. So it's rather easy to control it without knowing how to program. And the next step, and the step that we are also working on through the Erasmus project, is to start developing courses simulated environments for the FOSSbot GR, and also activities with the help of the educators that we have in that project. So this is once again the GitHub page of the project, and also the web application. And these are myself and Christos, the student that developed FOSSbot from the very beginning, and he's still working in my team, and we're both trying to improve it further. So thank you once again.